Every day, thousands of space rocks race through our solar system. But one collision can change history. Could the next one already be on its way?
For the first time in human history, mankind is preparing to change the path of an asteroid. This extraordinary mission could one day protect future generations from one of the greatest dangers hidden within our solar system. Across our solar system, millions of silent celestial bodies travel endlessly through space. Among them are asteroids whose future paths could one day intercept with Earth, carrying enough force to threaten life on our planet. Yet these ancient rocks are far more than a potential threat. Locked inside every asteroid are priceless records from the birth of our solar system, preserving clues to how planets, and perhaps even life itself, first began. Most asteroids remain safely within the asteroid belt, quietly orbiting the Sun for billions of years. But every so often, gravity changes the path of one of these ancient worlds. Nearly 50,000 years ago, a single asteroid struck this desert with tremendous force, leaving behind one of the best preserved impact craters anywhere on Earth. Traveling at nearly 50,000 kilometers per hour, the asteroid became a blazing fireball as Earth's atmosphere struggled to slow its incredible speed before impact. Within a fraction of a second, the impact released energy greater than many nuclear explosions, instantly transforming solid rock into a violent cloud of fire and debris. When the dust finally settled, a giant crater more than 1 kilometer across had been carved into the desert, leaving a permanent scar on Earth's surface. The explosion unleashed unimaginable power, sending a devastating shockwave across the surrounding landscape and permanently reshaping the desert within seconds. But this impact was tiny compared with another asteroid that struck Earth millions of years earlier, an event that forever changed the history of life on our planet. That single impact triggered global destruction, ending the age of the dinosaurs and opening an entirely new chapter in Earth's extraordinary story. Across the planet, astronomers stand as Earth's silent sentinels, constantly scanning the night sky with advanced technology to detect and monitor asteroids before they become a danger. To improve detection accuracy, multiple automated cameras observe different parts of the night sky at the same time. Their images are combined into one complete view, allowing even the faintest meteors to be tracked. As meteoroids plunge into Earth's atmosphere, intense heat strips away nearly 90% of their mass. That vaporized material is what creates the brilliant streak of light we call a meteor. Unlike human observers, these automated cameras never blink or grow tired. They watch the sky all night long, recording hundreds of meteors that would otherwise pass unnoticed. By recording hundreds of meteors every night, scientists can accurately reconstruct their paths through space, revealing exactly where these ancient fragments originally came from. When a larger object survives its fiery journey and reaches the ground, it becomes far more valuable to science, a fresh fragment of space that can finally be studied in detail. Among Giovanni's most treasured specimens is a fragment of the famous Ensisheim meteorite, the first meteorite ever witnessed falling by people in Europe back in 1492. In 1492, the famous Ensisheim meteorite fell into a quiet field in France. It became the first meteorite in European history whose fall was witnessed and carefully recorded. To reveal their hidden history, scientists carefully cut meteorites open. Inside, untouched minerals preserve a record of the earliest moments in the formation of our solar system. Every layer inside a meteorite contains valuable scientific evidence, preserving materials that have remained almost unchanged for billions of years since the solar system was born. Every microscopic structure inside a meteorite preserves information from the birth of our solar system, allowing scientists to study events that happened billions of years before Earth existed. These minerals are among the oldest solid materials ever discovered, surviving almost unchanged since the earliest formation of the Sun and its surrounding planets. Each meteorite is more than a space rock. It is a time capsule, preserving the conditions that existed when our solar system first began to take shape. Astrophysicist Patrick Michel believes these ancient asteroids preserve essential clues to the history of our solar system, making them some of the most valuable objects ever studied by modern science. To unlock its hidden history, scientists prepare an incredibly small meteorite fragment for analysis using one of the most powerful scientific microscopes ever built. At extreme magnification, scientists discover chondrules and olivine crystals, among the oldest surviving materials formed during the first few million years of our solar system. Under powerful microscopes, meteorites reveal an unexpected beauty. Their countless minerals create an extraordinary mosaic of colors, and every tiny pattern preserves clues about the history of our solar system. These ancient inclusions allowed scientists to determine the age of our solar system, about 4.567 billion years, preserving the very first moments after its birth. Just after the Sun was born, it was surrounded by a vast disk of gas and dust. Over millions of years, countless collisions slowly built the first planetesimals, the building blocks that would eventually become the planets of our solar system.
Each new discovery brings us closer to understanding our cosmic origins.